Now remember, I don't hate you that much. I do, but not that much. Haha. So, I'm not going to have you fill. You want to fill all these out? I don't want to fill these out. Do you? Because, look, okay, how do you make 5x squared? 5x and 1x. And then how many ways can you do 48? And you have to repeat them going the other way. No. Okay? But we could. But let's say I want to find out this one. All right? So I'm going to use the last box. I am guaranteed 5x times 1x, right? Yes. And then this combination and this combination have to make what? 48. Pick a number. 6 and 8. Okay, 6 and 8. So this is 6x and this is 40x. Will that work? No. Will it matter if I switch them? Yeah. Yes, it will matter. It may not be right, but it does matter if I switch them, doesn't it? Because the other one then hits the 5. And I get what combination? 8x and 30x. Oh, would you rather be lucky or good?
Good.
No, I'd rather be lucky. Then I don't have to be good. But can you guarantee being lucky?
No.
No, that's why you have to be good. All right? Anyways, boom, we got it. Luckily. Now, I'm going to show you another way that some people like, some people don't. This method that we just did depends on luck. Okay? But you get a sense of where the numbers go and try different combinations. Like I didn't try 1 times 48 first. You know what I'm saying? That's like crazy. But here's another method that you might like. Take 5 times 48. Multiply this is a whack method, okay? Just like crazy. And if I do that, I get 40 carry the 4, 240. Okay? Now, this method also lists things, but it's in a sequential pattern so that it's not random, it's not luck. We'll eventually get it. This method has hope. The other method, you don't know, right? If you're ever going to get the right answer. So here's what we do. So we're going to see where I got the 8 and where I got the 48. First and last time, you just multiply them for some reason. Then I break it down. 1 times 240, 2 times 120, 3 times 80, 4 times 60, 5 times 48, 6 times 40, 7 I don't think works, 8 times 30. Now, boom! You have to see something. 8 and 30 have something to do with 38, don't they? Whereas none of these had anything to do with 38. Whether you add them or multiply them, no. Whether you add them or subtract them to get the 38 is what you're looking for. Now, this is 5x squared plus 48, right? Now, I'm going to write 8x and 30x. Who should go with the 5x squared? The 8 or the 30? Doesn't 5 and 30 look good together? Like they're both divisible by 5? So I'm going to put plus 30x here and then plus 8x. Is that still 48x? And then we'll do what we did yesterday. Group these two. What's common? 5x. Who's left? And then these two, what's common? 8. Who's left? And what's common? And who's left? And you're right. This other method seemed faster, but that's if you're lucky. This one, it may take a little longer, but you know you're going to get there. You can see the path coming. So the first method here, let's start with things that were guaranteed. 12, well, there's no guarantee. There's lots of ways to make 12. But I'm guaranteed t, something t, and something t, aren't I? And the signs, we'll do that last, because that's easy to put in at the end. 3, we're guaranteed. 3 times 1, or 1 times 3, doesn't matter. Okay? So then now we just try stuff. So how can I make 12? 4 and 3, so 4 here, 3 here, let's see what happens. So this is 9t, I'll write it down. This is 4t, and ooh, we're done. We got lucky. How do I make a negative 5t?
14 minus 3.
Before that, though, here and here, how do I make a negative 5t? Negative 9 plus 4. How is the 9 going to be negative? If the 3 is negative, right? How is the 4 going to be positive? If the 1 is positive. Done. But that's because it just worked. Right? Method 2. 12 times 3 is 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. Ding, 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 ding. 4 and 9. You see a 5 coming out of that? This time by subtraction, right? So then I'm going to have 12 t squared, big space, minus 3. 4 and 9. Who looks good with the 12? And who looks good? Yeah, I think so too. So let's do the 4t. And who looks good with the 3? The 9t. Now, this still has to be a negative 5t, right? So like you just said, the 9 has to be negative, the 4 has to be positive. Okay? Then I group them. These two, who's common? 4t. Who's left? 3t plus 1. And who's common here? Negative 3 is good. And who's left? Same thing, I hope. So who's common to both? 3t plus 1. And who's left? 4t minus 3. Here we were lucky. Here we were good. Up to you how you want to approach these. Now, big numbers, big numbers, big numbers. Oh man, there's going to be so many ways to do this. So, what you do is you remember yesterday's lesson. And what did we do yesterday? Take out common factor. I think something goes into all three of those. Any ideas? Good. There's a shortcut for testing for 3. What's 2 plus 4? Does 3 go into 6? Therefore 3 goes into 24. 4 plus 2 is also 6, and clearly 1 plus 3, they're all 6. But if 3 goes into the sum of the digits, 3 goes into the whole number. Nice little quick test. Only works for 3 and 9. Don't try it for anything else. Who's left?
8x squared.
8x squared is good. Plus, I think it's 14x. Everybody plus?
Plus 5.
Plus 5. Okay? So we could try numbers and do the luck method. But let me show you the other one, because maybe that's the one you'd like to see more practice in. So, 8 times 5. Okay, go ahead and use your calculators. 8 times 5. 40. Just the 40. 1 times 40. 2 times 20. 3 times. Doesn't work, huh? 4 times. Ooh! Do you see something?
Yes.
You see the 14 coming? Okay, so don't lose the 3. 8x squared. Which of these two looks good with the 8x squared? 4 plus 4x, and then what? Plus 10x. That's 14x written differently, huh? And then good. That's next to the 5. They look good together, don't they? The first two have what in common? 4x. Good. Who's left?
2x.
Keep going.
2x plus 1.
Good. Plus, who's common in the last two?
5.
Who's left?
2x plus 3.
Surprise, surprise. Same thing again. So we leave the 3. We have the 2x plus 1 common in both. Who's left?
3 plus 5. Or no, 4x.
4x plus 5, right? These are the easy ones. If I have this, how do I make the first term? 7x times 7x. How do I make 1? 1 times 1. How do I make a negative 1? Plus and minus. But there's only 2 terms here, huh? Something must have happened to the middle term. Well, what's this? 7x, and this is what? I love these. These are the easy ones. But they only work if the numbers are real special, huh? If they are squares and we're subtracting. Adding makes it impossible. Subtracting makes it possible. Catch that? Adding will never work. Can you factor x squared plus 25? You might think so, huh? X plus 5, x plus 5. The x squares work, the 25 works, so what's this?
10x.
There's no 10x up there, is there? So adding will not work. These, I don't treat them as anything special. Okay? We just do the same thing as before, but the luck here is easy luck. How do I make x to the 6th? X to the 3rd times x to the 3rd. Because, watch. What does x to the 3rd mean? X times x times x? What does x to the 3rd mean? X times x times x? When I multiply them together, I get 6 of them. You want to see a bad mistake? This is a bad mistake. People will say x cubed times x squared is x to the 6th. Not if you string them out. Think of exponents the long way. String them out. You'll never make a mistake. If you try to use rules, good luck. You're supposed to add the exponents or multiply the exponents. You will never remember. Just string them out, right? Much better way to do these. And then how do I make 64? 8 and 8. Let's try the ones that are the same. And y squared,
8y.
y and y. And then let's put plus here and plus here. What's this? 8.
8y, I see.
Good. And is this another 8 of them? 8 of them, and 8 of them is? Dun dun dun. This is great luck. Easy luck. Not always going to happen, but you try it first. If it doesn't work, then you try the other thing we did just a moment ago. This one, we have cubes. And this one you may never have seen before in your whole entire life. Okay? I'm going to do that, and I'm going to start with these two and factor it to what's here. Okay? And here's how we do it. In both cases, when you have cubes, something times something times something, you'll have 2 terms and you'll have 3 terms. 2 terms and 3 terms. Okay? That's the first thing you have to memorize. Not too tough though, I hope. Second, S-O-P, SOP, which stands for same, opposite, and if anybody in your family is in the military, they will call this standard operating procedure. You might ask them if that's true. Same, opposite, and then positive. So, what sign is right here? Subtraction. Same, opposite, positive. What sign is right here? Same, opposite, positive. Got it? 2 terms, 3 terms, same, opposite, positive. Now the rest is kind of easy. What makes 8x cubed a perfect cube?
4x.
2x times 2x times 2x. 2x. What makes 27 a perfect cube? 3 times 3 times 3. Let's go over here. What makes 125 a perfect cube? 5 times 5 times 5. What makes x to the 6th a perfect cube? X squared, 2 of them. X squared, 2 of them. Now you have 4. Remember, string them out. I don't know if you ever saw people that cut paper dolls and string them out. That's exponents. You're just stringing out the same thing over and over and over. That's all it is. X squared. .64. I know you see 8 right away, but what times itself again makes 64? 4. Yeah. 64 is one of those special numbers. It's both a perfect square and a perfect cube. It's special. And then y cubed is easily y times y times y, right? So what makes them cubes? Right? So then 2x times what is 8x cubed?
4x squared.
Good. 3 times what is 27? 9. 5x squared times what is 125 x to the 6th? 25, good. X to the 4th, good. 4y times what is 64y to the 3rd? 16, good. Y squared. That part's not too tough. Just have to think about what numbers work. And actually, this last part's the only one that doesn't make any sense. Multiply these, ignore the sign. What do you get? 6x. Multiply these, ignore the sign. What do you get? 20 x squared y. Okay. Now we're done. but I want to show you something. You don't have to do this, but I think it's interesting. Multiply here, what do you get? 8x cubed. Of course. Multiply here, what do you get? 12x squared. But what do you get here? Negative 12x squared. That's good, because it doesn't show up here, does it? What do I get here? 18x. But, hold that thought, what do I get here? Cool. And then finally, what do I get here? Negative 27. So that this is a 0, this is a 0, and sure enough, I get what I was supposed to start with. Right? First thing I would look for when you have big numbers, is there a common factor? And I don't think so. Because what's 169? 13 times 13, and 13, each of them are prime. I mean, you can't break it up any other way. So then, 13, how do I make u to the 6th? U to the 3rd, u to the 3rd. Now, real quick, because people make this mistake all the time. What if this is u to the 9th? Would it be u to the 3rd, u to the 3rd? No, that would be like, nothing would work actually. But it's a trap. Okay? And then how about 144? 12 and 12. And v to the 4th? V to the 2nd, v to the 2nd. And the signs have to be plus and minus. So for E, you see the cubes. Step 1, what do you do? 2 terms and 3 terms. Step 2, what do you do? Same, opposite, positive. What's the same in this case? Subtraction, then opposite, positive. Good. And then, look at the first spot. What goes there? 4, good. A, good. Those are the cubes that make the 64, A, the third, a perfect cube, right? What makes B cubed a perfect cube? That's easy. B times B times B. How are we doing? Right? And then, what's going to make this one? 16, A squared, good. What's going to make this one? B squared. And then, do you remember how we got the middle term? Just multiply these two together. 4AB. And we're done. Common factor. And I think 3 goes into both. So if I take a 3 out, who's left? X squared minus 25y squared. And now the numbers are nice. That's the difference of 2 perfect squares. Don't lose the 3. How do you make x squared? X times x. How do you make 25y squared? 5y and 5y. And how do you make a negative? A positive times a negative. I suggest you do the sign last. If you do the sign first, you might paint yourself into a corner kind of idea.